Hi, welcome to the soil health demonstration field here in Clay County. I'm Matt Fryer with the University of Arkansas System Division of Agriculture Cooperative Extension Service. I'm joined today by Allison Howe, Clay County Extension Agent. And this field, this soil health demonstration field is funded by NRCS, and also we're getting some double duty with the Cotton Verification Program funded by Cotton Incorporated. So we're very grateful for the funding that we received on this demonstration field. And so in this field, we're splitting it in half, where we have no-till and cover crops on one side, and then conventional production practice on the other. And we're comparing a bunch of different soil measurements, aggregate stability, bulk density, routine soil tests for nutrients and pH, and some soil health measurements as well. And so I'd like to demonstrate those now. So before we get into how to take these samples, I'd like to just touch on what soil health is. Soil health really encompasses the three main areas of soils, and that's physical properties like aggregate stability, how well the soil holds together, bulk density, soil texture. It also encompasses the chemical aspect of soil like pH, nutrient concentrations, organic matter. And then it also encompasses the biological aspect, microbial populations of fungi and bacteria and earthworms. And so soil health really is a encompassing term, and so we have to take a lot of soil samples and different measurements to really encompass that. So what we're doing in these soil health demonstrations, we're taking, of course, routine soil samples that we use this probe for. It's got a stop washer at 6 inches, which is the correct depth for cotton. And so we'll go across the field. We'll take 25 or so cores in a 20-acre field, put each core in a bucket, mix it up, and take a subsample from that and send it to the lab. We can also take the same soil and submit for soil health tests that do a lot of biological measurements. And so that gives us that information. And so another important measurement that we take is bulk density. And so this just gives us how compact the soil is. And so bulk density is just the weight of soil in a given volume. And so we use this slide hammer in this cup. And then we take this cylinder, the soil's inside the cylinder, and we level it off because we know the known volume of soil in this cylinder. And then we dry it and weigh it in the lab, and it gives us bulk density. We also take aggregate stability samples, which again is how well the soil holds together, how well it forms the aggregates and allows water to infiltrate the soil. And we do it the same way we do bulk density. We just use a larger cup. So I've already taken this just to save a little time. And so we take that knife and we cut off the top 2 inches or so, because aggregate stability differs as you go down the soil profile. And then we do a 2 to 4 inch sample as well. And so all of the aggregate stability, bulk density, all of this matters, and really, in my mind, affects water infiltration, which is a huge key. And so we're also doing water infiltration measurements with these units. They're automated. They're called a Saturo. And we have the computer head and pump here, a water source, and a ring that I pounded in the ground, and then I clamp this head on to the top. And so it pumps water into the ring, up this head to a certain pressure, and as water soaks in the ground, pressure decreases in the pump nose to pump more water. And so it typically takes these, depending on soil texture, anywhere from 1.5 hours to 3 hours to run a cycle. And it gives us a lot of information about water dynamics in the soil. And so, you know, why does all of this matter? Why do we care about bulk density, aggregate stability, how well the water soaks in the ground? You know, in cotton, I feel like we spend a lot of effort and money putting Band-Aids on things, especially issues like potash fertilization, potassium fertilization in cotton, where we have adequate potassium levels, but the crop's telling us otherwise. And so I really think the issue has a lot to do with these soil physical properties that I just talked about, preventing root penetration down the profile. And so we've got a really shallow root system in a lot of our cotton acres, preventing nutrient uptake and just making it hard for the cotton plant to really take up nutrients like it needs to. And on top of that, water's not soaking in the ground like it could be. You know, a lot of times we have water infiltration only down to about 6 inches when we look at moisture sensors that we're using in these fields in the no-cover tillage side. When we implement no-till and cover crop, that water infiltration goes down 12, 18, and sometimes 30 inches deep. And so a lot of our nutrients, our crop nutrients, are taken up by the plant via water. And so if water's not getting down past 6 inches, then the plant's certainly not taking up much nutrients past 6 inches. So we're really handcuffing our crop when we don't have good soil structure and water infiltration. And so these are just some of the things that we're looking at in the soil health demonstrations, and I hope this was beneficial to you. Again, thanks for joining, and again, I'd like to thank our sponsors, NRCS, and also Cotton Inc. for sponsoring the Cotton Verification Program. Thanks for joining us.